Okay, this is the first problem from the prerequisite homework. It wants you to enter an equal if the proposed identity holds and n if it doesn't. So when you multiply the first one together, what you should get is 1/2 times 1/2 will give you 1/4. And then a times b will give you ab. So that's what it should be, and it's not. So we're going to enter in an n here. Okay. The next one should be 1/4 again, because 1/2 times 1/2 gives you 1/4. There's not a 4 down here, so that's not true. This one does give me the 4, so that is equal. And then 1/2 a times 1/2 b does give me 1/4 ab, so this one is equal as well. All right, so the second problem, it wants you to enter in true if the statement's true and false if it's not. Okay, so for all real numbers a and b, a plus b equals b plus a, that's true. That's actually the a property of addition, that it doesn't matter if 2 plus 3 or 3 plus 2, you're going to get 5 either way. Next one, the square root of a squared plus b squared equals a plus b. That's not true, so we're going to enter in false for that one. Yeah, you definitely can't do that. You can try it with numbers, you'll see that it won't work. But never do that. If you have the square root of you can only simplify a square when you're multiplying. So if it's a squared times b squared and you're multiplying, then that does simplify to a times b. So if you're multiplying, you can simplify it, but not with addition. Okay? For all positive real numbers a, anything to the 0th power does give you 1, so that would be true. All right, so let's skip ahead to number 6, because that sounds like it's a tougher one. It says the problem addresses some common algebraic errors. It wants us to enter in t for true and f for false, again, for these equations. So when I FOIL this out, so this is a quantity that I'm squaring. When I FOIL that out, you can do it over here if you want, on the side. But when you do this, you're going to get x squared plus 2xy plus y squared. So you can see that says it's true because we're missing that middle term right here. All right, so we would enter in false right there. So for the next one, when you FOIL this out, you do get this quantity right here, right? Because that's what you get when you FOIL this out. So it does have the 2xy, so that is true. Okay. For the next one, now this is a tough one. We have x over x plus y. Let me clean this up a little bit. All right, so we have x over x plus y equals 1 over y. All right, so somehow I want to try to get this denominator to look like this denominator. Right? I want to find out if this is equal. So what I'm going to do is I'm going to multiply the top and the bottom of these fractions by something to get a common denominator on both sides of the equation. So I'm going to multiply the top and the bottom of this fraction by y. And I'm going to multiply the top and the bottom of this fraction by x plus y. Because then I'll have the same thing. You can multiply the top and the bottom of a fraction by a number, and that doesn't change the fraction. So I'll multiply the top and bottom of this one by y, top of this one by x plus y. That gives me y times x equals, or over y times x plus y. And on the right side, it gives me x plus y over y times x plus y. Now, y times x and x plus y are not always the same. So this is not true. So it's going to be false. All right, so the next one then, if you distribute the negative sign, you get x minus y equals y. Right, all I did was distribute that negative sign to both of these. The x's then cancel, and I get negative y equals y, which is not true. So I would enter in false. Okay, the next one is x squared square rooted equals x. Well, when you take the square root of x squared, you actually get plus or minus x. So that's not true as well, because the left side of this equation, when you take the square root of x squared, you get plus or minus x, because it could be a negative underneath here. So that's not true as well. All right, and then the next one, the square root of x squared equals the absolute value of x. That is true, because the square root of x squared gives you plus or minus x. And when you evaluate the absolute value, it doesn't matter. You could stick in a plus or minus x. And when it comes out, this is a little bit of a tricky one. You can think about entering like a -2. If you enter in a -2, you get -2 squared, which is 4. Square root of 4 is 2. That's the same thing you'll get if you enter a -2 on the right side. You can try any number, positive or negative, and you'll always get the same thing. So, it'll always work. You can try any number you want. This is true. Okay, the next one, square root of x squared plus 4 equals x plus 2. This is not true. You can't take the square root of two things individually like that. This was the same thing in the last problem, or one of the previous problems. You can only do it when you're multiplying. So if you would have had the square root of x squared times 4, then you could take the square root of both things and make it x times 2. But because you're adding, you can't do that. So that's false. All right, and then the next problem, we need to figure out if this is equal right here. Let's just try to simplify this one by hand. So you get 1 over x plus 1 over y. I want to add these two fractions together. To do it, I need a common denominator. Next problem is number 7. Let's delete 7 from both sides for the first one. And you get 2x equals negative 5. Divide both sides by 2. And you get x equals negative 5 halves, or 2.5. Well, you can enter in, I believe, negative 5 halves, just like that. It should work. Let's see. For the following equations, enter u if the equation is unique solution. No. Okay, so all it wants us to enter, this does have one unique solution. So we just need to enter in a u. That's it. What this is, if you guys remember from Algebra 2, I know this is all review, is this is a line and a line. So like if you were to look at a graph of this is a line with a slope of 2 and a y-intercept of 7. So it goes up like that. And this equation 2 goes like this. It's a horizontal line. So the answer is negative 2.5 where they intersect right there. Okay, so there's one unique solution or one unique intersection. Okay, next problem. Wants to know when these two lines are equal. Well, these two lines are the same line, except for they have the same slope. One of them goes through 2 and goes up 2 over 2, so it goes like that. The other one goes up, starts through 7, and goes like that with the same slope. So there's no solution to these because they're parallel, but they don't go through the y-intercept, so there's no solution. That's an n. Okay, so for this one, the next one, looks like there might be one unique solution, but I'm not sure. For this one, I'd probably just graph this in your graphing calculator, both the top and the bottom. Might be the easiest way to go, so let me pull that up. All right, so let's just enter both these in. So go to y equals, and we're going to enter in 1 over 2x plus 7. So alpha y equals 1 over 2x plus 7. And then for the next one, we're just, I'm sorry, yeah, 1 over 2x plus 7, and then 1 over 7x plus 2. And then we're just going to hit graph. And let's just look to see how many solutions there are. Okay, this is a tough one, but it looks like there's one solution. It looks like it's over here. This graph comes down, and so does this one. So let's, I don't know, I guess let's zoom. I'm going to zoom out, though, and just take a look at it from a bigger angle, because I really don't know. Okay, they're both hyperbolas. This one is a hyperbola here. The other one's a hyperbola there. There might be two solutions. Let me see here. It says, enter u if the equation has a unique solution, no if it has no solution, if it has infinite many solutions. I'm guessing it's a u for unique solution. If you look at the graph, it looks like there's two solutions potentially. Let's try a u and see if that works. All right, so there is one unique solution to this. It turns out that they did intersect. If you zoomed in, you could find they intersect exactly once on both sides. So we'd say it's a unique solution. So let's put a u there. This one, they're the same, but this one's one bigger in the numerator, so they're never going to be equal on both sides. No matter what you stick in for x, you're never going to get an equation on both sides, so they're never equal. This, if you FOIL it out, gives you the same thing on the right. So that's an infinitely many solution one because it's the same on the left and right. So no matter what you stick in for x, it's a solution. Same thing with this one. It's the same on the left and right, so no matter what you stick in for x, it's a solution. Okay, the next question says let x over y be a fraction reduced to the lowest terms that satisfies this equation that's given. So basically what I'm going to do is then solve for x and y, because that will give me x over y. I'm also going to make sure that it's reduced as well. So what I'm going to do is multiply both sides of this equation by 7 over 3. If I multiply both sides of this equation by 7 over 3, the 7's cancel, the 3's cancel, and I have x over y equals 7 times 6 and 5 times 3. Sorry. So I do need to simplify this. Let's think of a number that goes into both the top and the bottom. So 3 goes into the top and the bottom. 3 goes into 42 14 times, and it goes into 15 5 times. So this reduces to 14 over 5, so x would be 14 and y would be 5 then if it was reduced.